Welcome back everybody to my channel. My name is Bilkis. In the last class, we treated letters for numbers, meaning that we saw how we use letters to represent unknown values, and then we will now calculate the value later on. So I think the one we did last class was on division and multiplication. Do you understand? So today we'll be going to something different entirely. Although in a way they are somehow the same, but it's a bit different. Now I want to look at sentence completion using numbers. We want to complete certain mathematical sentences using what? Numbers. Alright, now in each of these mathematical sentences, there are two or more boxes. Now you're going to put the same number in each of the boxes. That is, whatever I put here is what I will put here, is what I will put here. And it has to make this whole statement to be what? True. So I have to put the same number in each of these boxes to make the sentence what? True. Now the fact that if I put any number I put here, does not mean that I have to put the same thing here. No. Each line, number one, you treat number one separately, you treat number two separately. Does that make sense? Now before we dive into this video fully, I say a very big welcome to all of you, to returning viewers, and for the new viewers I say welcome to you too, and I say a very big thank you to both of you as well. So if you haven't subscribed to this channel, please do not hesitate to go ahead now and subscribe to this channel before we go on, and don't forget to hit the bell icon before the subscription button. And as much as possible, please do not forget to share this video with as many people as possible that may need this content, especially during this pandemic. That physical school has become, is gradually becoming virtual class rather is gradually becoming a normal thing now. Do you understand? All right, it's gradually becoming a new normal. All right, so please try as much as possible to push this content to as many people that need it, especially during this pandemic, as possible. And please, if you need any question as to any of the content that I've been pushing forward so far, you can reach out to me via the comment section. All right, now let's go into it. So now I have the first example I have here is 18. I have 18 equals to dash plus dash plus dash. Now the fact that we've been given the rule, this is somehow, the calculation here is not even much anyway. You just need a reasoning, a logical kind of reasoning before we can start. So we have been told that whatever we put here, whatever value that we put here, should be the same value we are going to put here, and should be the same value we are still going to put here. Does that make sense? So now that I have 18 equal to this plus this plus this, what does that simply mean? It simply means that we should look for a number such that when we divide 3 into 3 portions, what we get to be here is going to be here, is going to be here. So since we have 3 boxes here, I'm excited to say, oh, let me divide my 18 by 3 to see if I'm going to get it, because I have 3 boxes here. Now, and you know, in the case of addition and subtraction, they are somehow intertwined, in the sense that, for instance, if I say 2 times 3, for instance, now 2 times 3 means 3 into 2 places, or 2 into 3 places. You know, it will now give me what? 6. Do you understand? So the same way, you might want to look at this the same way. So in the sense that I have 18 to be equal to this plus this plus this, just like I have this 2 times 3. You know that when I say 2 times 3 equals to 6, it means 3 into 2 places. You have 3 plus 3. That's what it just means. Or you can even say you have 2 plus 2 plus 2. Do you understand? This is the same thing as this, and it's the same thing as what this. So you can see that this multiplication and division, they are somehow what? Intertwined. So let's see if you can apply this rule to this. Now I have 18 to be equal to this plus this plus this, meaning that I have a number that is appearing in 3 places. So if I have 3 numbers here, that means it is suffice to say that I can actually divide this by 18 by that number of boxes that I have up here. Meaning that I can say 1, 2, 3 boxes. I can say my 18 divided by 3. 3 here 1, 3 in 18 is what? 6. So I can say 6. Now let's test if 6 is actually the number. If I put 6 here, 6 here, 6 here, because I actually divided by 1, 2, 3 boxes. I divided 18 by 1, 2, 3 boxes that I'm given here. Why did I do so? Because I know the fact that in each of these 3 boxes here, I need to have an homogeneous number. I need to have a number that are the same, that will cut across the 3 boxes. Does that make sense? That's why I feel I can divide what? 18 by 3. Do you understand? And when I did so here, I got 6. Now let me test to see if addition of these 6, 3 of them, can actually give me what? 18. 6 plus 6 is what? 12. 12 plus 6 is what? 18. So that means we are correct, we're on the right path. So really, this kind of sentence completion is not a huge calculation, so to speak. You just need to put on your thinking cap. You need to apply your you need to be, it's just logical. You need to try and test and see which one is going to be which. Do you understand? All right, now let's look at this next example. 30 equals to dash plus dash. I may want to do it the same way I did it to make it easier and faster, you know, meaning that I have two numbers. When added together will give me what? 30. Now let's do it the way I did this. Because I have two boxes here, it then did me fit to say, oh, I'm going to divide my 30 by 2. Let's see. 30 divide by 2. Why am I dividing by 2? Because I have two boxes, meaning that I have two sets of numbers that I'm adding together to give me 30. So it is okay to now divide by what? 2 to see. Now I have, how many 2 can I get here? Is 1. How many 2 can I get in 3? It's 1. And I have 1 left here, because if I take away 2 from 3, I'll have 1. So the one I have left, I'll just place it right beside this 0 to make 10. How many 2 can I get in 10? Is what? 5. So I have 15 divided by 1, which is what? Is the same thing as what? 15. So if I have 15 here, it then means that I have 15 here and 15 here. After all, the number we need to have in the box has to be what? They have to be the same, all true. All right. So for this number, now if I'm going to check 15 plus 15, can 15 plus 15 give me 30? We need to check to see. I have 15 plus another 15. 5 plus 5 is what? 10. I'm keeping 1. 1 plus 1 is what? 2. Plus the one I'm keeping aside, that's 3. And that makes what? 30. Do you understand? All right. Now let's look at the next example. In this case, we have multiplication as opposed to the division that we have been having. I have 100 equals to dash times dash. Now, if you look at this, the operator here is different from this. The operator we have here, they are just what? They are addition operators. But here we have multiplication. Do you understand? So what do you need to do? Because we need to look for two numbers such that when we multiply them together, we are going to arrive at 100. So in this case, what do? It's very simple. All we need to do here is to do what? It's just like this thing just means 100. And even I'm representing this place with B, for instance. Do you understand? Because I need to have the same number here. And I have 100 here equal to, because B times B will give me what? B square. Do you understand? Now if B times C is going to give me B square, it then means that the value of my B that I'm looking for, B, will now be equal to this 100. And then you see this square sign. By the time it moves, this square sign here, by the time it comes to this side, it changes to what? Square root. My square changes to what? Square root. Do you understand? My B equals to what? 100. This square sign now changes to what? Square root. So what is the square root of 100? You might want to ask. The square root of 100 is what? It's 10. So meaning that our B is what? 10. So that means I have 10 here and I have what? 10 here. And if you want to check to see if you're actually on the right path or not, 10 times 10 is actually what? 100. Does that resonate with you in any way? All right. I believe so. Now let's go to the next example. Now I have dash divided by dash equals to 1. I could say B again and B. If I have B divided by B equals to 1, so what do you think logically should be numbers that are here? Now this is simply telling me that whatever number I'm going to divide here is going to give me 1. So if you need to start racking your brain and ask yourself, what are those two numbers that are the same, such that when you divide them by each other, you are going to arrive at 1. It's just any number. Any number. You know why I said it's any number? Because 3 divided by 3, it's 1. 7 divided by 7, it's 1. 8 divided by 8, 1. 1 million divided by 1 million, it's 1. So any number whatsoever that you are dividing with that same number will always give you what? 1. So if I choose to write 4 here, and I choose to write 4 here, and another person chooses to write 5 here and 5 here, they are still talking about the same thing. Does that make sense? Alright. Alright, look at this example here. I have a box here equals to 2 minus box. That is, what am I going to subtract from 2 that I'll still get that same thing? So I think what you just have to do to be on the safer side is just to ask yourself, is there any way I can divide these 2 into equal half? Yes. How can I divide 2 into equal half? That means I have to divide by 2. Do you understand? So if I divide 2 by 2, I'll get what? 1. Just like if I want to say 16 now, what am I going to do to get half of 16? That means I'll divide by what? 2 to get 8. So the same way, this one. Think of a number that you can think of trying to cut these 2 into half. Do you understand? So if you do that, that means you have 1 1. So that 1, when I found out the half of this, the half of 2 is what? Divide by 2 to give you what? 1. Now the half of 2 is what? 1. So that 1, if I'm subtracting it from this 2 itself, let's see what it's going to give us. half of 2 is what? 1. 2 minus 1 is what? 1. So that means it works. You can see that it's what? Easy. Now look at this example also. They are more or less the same, only that this value 14 here is bigger than this value. So what do you want to do in this case? The first thing you want to do also here is to divide 14 into 2 equal halves. And how do you do that? That means you divide 14 also by what? 2, so that we can get the half of what? 14. So 14 divided by 2 is what? 7. Meaning that 7 is actually the half of what? 14. So let's see, let's try and subtract that 7, which is the half of 14, from 14 itself. So 14 minus 7, what should it give us? It should give us what? 7 as well. So you can see that 14 minus 7 is actually what? 7. Do you understand? Alright, thank you so very much for watching today's video. The next class promises to be more enlightening. Please do not forget to subscribe to this channel and hit the notification bell so you'll be the very first to know anytime I push out the content. Thank you very much, and I see you in the next class.